Hi everyone. Today I'm going to start the discussion from the same topic related to the extended service stage and the basic service stage. These are these are named to service stage of wireless local area network WLAN. Now I told you the standard of this WLAN that may be uh, categorized based on IEEE 802.11. So when I'm talking about the IEEE 802.11, then this 802.11 has different other standard benchmarks. Those are related to A, B, G, N, etc. Now, next to that, I have discussed in case of extended service set, one DSS may be present or coexist with another DSS. This is one DSS. This is another DSS. They may coexist at a particular point, something like this. Then some node may be present over here. This is our station. This station may access the information from this side, from this access point, or it may access from this access point. Any one of them. It's not mandatory to access this one, or it's not mandatory to access this one. You can access based on its priority and better service, quality, etc. Now, all those DSSs are connected with one distributed system. One distributed system may be connected with some server. This is our distributed system, and this is our server. Any distributed server or some gateway. Now, that means we have found main concept behind WLAN, that is related to three components, or it may include three components: ESS, extended service set, or BSS, basic service set. And obviously, one most important thing, access point. These are the various components. Now, I told you what are the different types of stations. There are three stations. In case of IEEE 802.11, there are three stations. One is our IEEE 802.11 based node transition, or it may be BSS transition, or it may be ESS transition, mobility based scenario. Okay, so these are very important things. Now let's discuss about the MAC sublayer. IEEE 802.11 defines two MAC sublayers. One is PCF, P for point, C for coordination, F for function, and DCF, D for distributed, C for coordination, F for function, DCF and PCF. When I want to draw the MAC layers in IEEE 802.11 standard, then there have one physical layer, one data link layer. At the upper level, it is logical link control sublayer. Now there have two services. One is contention free service, another one is contention based service. Contention free service that may include PCF. Contention based service that may include DCF. And these are work over the physical layer IEEE 802.11 FHSS, frequency hopping split spectrum or sharing split spectrum or infrared, or some other standard based on IEEE 802.11. It may be A, B, G, N, etc. Actually, N is used. IEEE 802.11 N. I'm talking about IEEE 802.11 N. And this is used for MIMO applications. MIMO means multiple input, multiple output antenna application, advanced antenna applications. Now, when I'm talking about distributed coordination function, this DCF uses CSMA, CA protocol. What is CSMA? Carrier sense multiple access. What is CA? CA is collision avoidance. So DCF uses CSMA CA access method. Wireless LANs cannot implement CSMA CD for three different reasons. For collision detection, a station must be able to send data and receive collision signals at the same time. Okay, this can costly, or it may enhance the cost of the system, So another reason that may be found in case of our CSMS CD, that is cost effectiveness, that is less, and the bandwidth requirement, that is also very high. Collision may not be detected because of the hidden station problem. Because of the hidden station problem, something is not maybe seen due to some obstacle, due to some other problem related to some channel characteristics, etc. So station may be hidden, and collision that may not be detected. The distance between stations can be great. Signal fading could prevent a station at one end from hearing a collision at the other end. So these are the reasons why should I use CSMS-CA over CSMS-CD. Now, when I'm talking about the CSMS-CA, before that I want to tell you few more terms. One term is distributed interframe space, DIFS. Distributed interframe space, that is DIFS. Another term, RTS. RTS is request to send. Another term is SIFS. Another term, CTS. What is SIFS? Short interframe space. What is CTS? Clear to send. Now, what is exactly DIFS? After the station is found to be idle, the station waits for a period of time, that is called DIFS. Then station sends a control frame, that is known as our RTS. After receiving this RTS and waiting for a periodic interval, that is SIFS, the destination station may send a control frame, that is known as our CTS. The source station sends data after waiting an amount of time equal to SIFS. So these are most important 4 terms. Along with that, I want to define another thing, NAV. What is NAV? Network allocation vector. The key feature of NAV, that is something like this. You may think just in this way. When a station sends an RTS frame, it may include some duration of time that it needs to occupy the channel. The stations that are affected by this time transmission create a timer that is called our NAV. Okay. Now let's discuss about CSMS-CA. Already I have discussed about the term DIFS, SIFS, etc. First, when it may be started, then next to that, there have one backup time. That backup time may be allotted as 0, first level. Then it may wait for a random time interval using persistence strategy. After that, it may wait for another time interval that is known as DIFS. Then it may send RTS towards destination and set a timer. Why? Because within this time interval, if some information may be received at the source, something like acknowledgement, that may be reverted back, then fine. If it cannot be found within a certain time interval, then what happens? Then it may be thought that information may be lost. So we need to set something like one alarm. This is the time requirement for that purpose. So set a timer. Then next, if CTS received before timeout, then fine. Wait for SIFS. Then after that SIFS interval, it may send the original information or data, that is frame. Then set another timer. If after that time interval some information may be received, that means it is unsuccessful or failure. If the information, something like acknowledge information, may be received before that, then it is success. So these two things, this one and this one, may be categorized under the same category, and then these are simply like a failure. Then it may increment its backup value from 0 to another level 1. If second time failure, then it may be enhanced to 2, something like that. Then what about the backup limit? Is there any backup limit? Yes, of course. And that backup limit may be computed based on, in this way, say 2 to the power n minus 1. Say it is 15 number of value may include for backup limit. If it may beyond that, that means this total output is just not under control. So the system failure. That may be defined as abort. Otherwise, if it is less than backup limit, then wait for backup time, and again it may be started in this way. So this is a loop. When I can see in this way, it is something like this. First GIFS interval, then RTS may be sent, then SIFS, then CTS may be sent, then another SIFS, then data may be sent towards destination, then SIFS. After that, acknowledge may be received, and when nav value may be used, no carrier sensing purpose, then when a station sends its RTS, it includes time of how long it needs the medium. Other stations then set their nav value to this time, so they don't transmit, okay, to avoid the collision. And already I told you what is GIFS and what is SIFS. Now see example of repetition interval. First, on access point, we send some information, or it may receive some information, but before that it needs to wait for a particular time interval, which is known as some PIFS. PIFS is another important time interval which is known as PCF IFS. Already I told you PCF. What is PCF? Point coordination function. And IFS means inter-frame space. Then beacon may be transmitted. Beacon frame may be transmitted. After that, another time interval SIFS. It may be required to wait for that. Then it may arrange some pole, and after that, poled station, there are different stations, and one of them out as the poled station, then it may wait for a SIFS interval of time. Then acknowledgement plus data that may be sent from this. Then another SIFS time interval may wait from this end, and then it may arrange another acknowledgement and polling arrangement. Then after that, in this way, it will get the absolute output from all those stations. And these are everything that may be computed or controlled from this point of view in NAV. And this total interval is known as repetition interval. This is repetition interval, and this is contention free, and this is contention based. Okay, out of this polling, okay, when everything is completed, then anything may be happened, then this is based on contention. Now when I'm talking about the frame format, what is the frame format of any MAC layer frame? There may be some information that is FC. FC is frame control information. This includes 2 bytes of information. Then D. D is something related to the duration of the transmission, to another 2 bytes of information. Then address 1. It is actually 6 bytes of information, and each address fields depends on the value of the to DS or from DS. subfields. These are most important terms. DS, this is the main component I told you about this frame format. So in this way, address 2, address 3, etc. SC means sequence control, how to control the sequence of a frame, another 2 bytes of information. Then another address, some frame means main information, main data. And last one is something related to error control or error checking purpose information. That is FCS, 4 bytes of information. What about the FC? FC may include protocol version, type, actually the type of information, maybe management or control or data information. That's why either it is management, so 00, either it is control information, then 01, either it is data, then 10. So 2 bits of information. Subtype of each type may be defined in this particular section, where 4 bits of information may be sent to define this thing. 2DS and from DS. Already I told you that this DS information is the one of the most important thing. Okay, so this DS is the data stream related, all these things may be controlled over here. Now another thing, flag information, something like the change, any change, fragmentation change, everything may be controlled by this thing. Next to that, it is the part of our issue related to retry or power management, data information, then wired equivalent privacy, that means encryption control that may be defined by WEP, some reserved information, etc. Okay, so this is the frame format of our ACLER.